Hey there, DePenguineers. My name's Elan, a student teacher from UCSB, and I'm here to teach you about how to use the oscilloscope. This is one of my favorite pieces of electrical equipment, and here at the Engineering Academy, we're really blessed to have 4 or so oscilloscopes. Each one of these bad boys costs about 800 bucks, so really privileged to have access to such a great piece of equipment. Let's learn how to use it, shall we? So right here I have our pulse width modulated circuit from Unit 4 of the sophomore year. As you might remember, as I turn my potentiometer, the brightness of these 2 LEDs goes up and down. How does that happen? Well, we modulate the width of the pulses. We change their widths, we modulate them. We're gonna see on the oscilloscope what that looks like. Let's try that. So, the oscilloscope has this little probe here, which has 2 parts that stick out of it. A little clip, and then another clip that you can pull down. Some probes are a little different. Some of them you just stick directly into the breadboard. So these go across whatever component you're trying to measure the voltage across. So for our PWM circuit, we want to measure the voltage across one of the LEDs. So what I'm going to do is I'm going to clip onto one side of an LED and then clip onto the other side of the LED. All right, and now you notice that our oscilloscope is tripping out a little. It's detecting something. So initially, it's going to be a very noisy signal, and it's not really going to make much sense. So I recommend hitting the auto button up here to sort of let the oscilloscope figure out what's going on. Let's do that. Oops. There we go. So now we have a cleaner signal. You can sort of see that we have a bit of a square wave going on where it goes up and then back down and then up again. There still is some noise in this signal. Just ignore the noise. We don't care about the noise. So if you want to adjust your signal further, which I recommend you do, your main areas of interest on the oscilloscope are these knobs right around here. So we can adjust the vertical position with this knob. We can move our picture up and down. We can adjust the we can adjust the vertical scale with this knob. So we're zooming in. I went out of our picture, so notice that I need to bring it back in by changing the vertical position. And we can zoom out and again adjust our vertical position. Same thing for the horizontal position. We can move it back and forth with this knob and zoom in and out horizontally with this knob. Cool. Another important thing to look at are the numbers down here. So these numbers tell you the volts per division. So if you look closely, you'll see that there's sort of an XY grid on the background of your oscilloscope. See these like white dotted lines? Yeah, oscilloscopes are exciting. So we have these dotted lines in the Y direction are telling us the voltage. So really what we have here is a graph with voltage on our y-axis and time on our x-axis. So it's telling us how the voltage varies over time across the LED right now. If we want to know the exact number though, we have to look over here. So 2 volts per division. So right now, each one of these Y markers, tick marks, tells it is 2 volts more than the previous one. So if I were to just zoom in on the signal a little bit, and then move it so that the bottom of the signal is aligned with this X line right here, I can look how much higher is the top of the signal than the bottom. So from here to here, well, there's 1, 2 white lines, which means that we're going up 1 volt and then a 2nd volt. So our signal, the maximum value of our signal is 2 volts here. Right? If it were up here, it would be 3 volts. If it were up here, it would be 4 volts. All right, and then on the x-axis, this is telling us that each x tick mark represents 1 millisecond. Sometimes you'll see a U here instead of an M, and that would mean microsecond, or 1 millionth of a second. But here it's M for milli, or 1/1000th of a second. So I'm going to adjust my horizontal position so that I get the beginning of a signal aligned with one of these straight up and down lines. And then if I want to figure out the period, that is how long it takes until the signal repeats itself, I just need to look over to where the signal repeats itself. So it starts going up here, and then the second time it starts going up is right over here. And I see 1 full tick mark, and then maybe a quarter of the next tick mark. So that would mean this is 1 millisecond and then a quarter of another millisecond. So 1.25 milliseconds would be the period for this signal. You can also you can press this measure button over here and then sort of choose what measurements you want to display. If you want to access the maximum voltage, you can throw that on here and it'll tell you in real time. Careful with these automatic readings though, because they will read the noise signal, right? All of this crazy stuff going on, and that could throw off your values. It's probably safer to just use your eyes and common sense about what is noise and what's the actual signal that you're looking for. And then lastly, I'll add that if you want to display all the possible readings, you can press this measure button and then press this button here, and it'll give you every possible reading that this oscilloscope can give. Way more information than you need, but could be interesting. So with that, I'll tell you happy oscilloscoping and enjoy learning all about electricity, because it's really quite interesting.